Great pleasure to have John Polkinghorne with us today. He's got a great number of prefixes to his name, and they actually all record slightly different parts of his career. So he's doctor, because he's got a PhD, he's actually professor, which records his scientific career of some 25 years, ending up as professor here in Cambridge. He's a reverend because then he left and got ordained, was a parish priest, and then came back, was president of Queen's College. President the right term?
Yes, absolutely. That's the right one.
Queen's College here in Cambridge, and has been ever since then very involved in the science-religion debate. He's Sir John as well, in recognition of many of those things, also for the fact that he's chaired many commissions and committees for the government looking at such things as the Advisory Committee on Genetic Testing. That was one of them. And of course in 2002, in recognition of his work in science religion, he won the Templeton Prize, which, as Sir Brian Heap was telling us, is always set to be slightly more than a Nobel Prize in value. So, John, we're really privileged to have you with us today, and we're looking forward to your talk. You're going to talk to us on natural theology, and I'll hand over to you.
Well, thank you, Rob. It's very nice to be here. I'm having a spot of back pain at the moment, which is why I'm sitting down. I don't like to speak sitting down. I rather like to loom over the audience, but I'm going to have to put up with that today, and you'll have to put up with it too, I'm afraid. Well, natural theology is the attempt to learn something about God from rather general experience, or you might say from the use of reason and the inspection of the world. If there is a God whose mind lies behind the order of the world and whose purposes lie behind the unfolding history of the world, it might be reasonable to try and see if there were some indications that that was so. They would be hints, of course. They wouldn't be absolutely straightforward. We don't expect to find the universe populated with items stamped made by God. But it would be very surprising in a way, and I think rather unnerving and unsettling, if one didn't see at least some sort of intimation that there might be more to the world, for example, than science on its own is able simply to tell us. And in fact, the search for a natural theology is a very instinctive and natural one, and a very ancient one. In fact, one of the earliest collections of natural theologians, I think, were the wisdom writers of the Hebrew Bible. Most of the writers of the Hebrew Bible are concerned with God's great saving and judgmental acts in history. They're concerned with the Exodus and things like that. But the wisdom writers, they know that the fear of the Lord is the beginning of wisdom, but they don't spend a lot of time talking about what the Lord has done in human history. They simply look at the world and they see what's going on, and in a rather cool way, they comment on it. They say things like in the book of Proverbs, a rich man has lots of friends, but nobody really wants to know a poor man. They don't endorse that view of the world.
Excuse me, can you slow down, please?
Probably not, but I will try. They don't endorse that point of view, but they see it like that. They say things like a gold ring in a pig's snout is a beautiful woman without understanding. And so the wisdom writers are there at work in their way. And of course, the greatest of all the wisdom writings, in my view, is the book of Job. In Christian intellectual history, there have been two particular periods when natural theology has flourished. One was in the later Middle Ages, and we associate the names of people like Aquinas and Anselm with that. It was an age where people were particularly concerned with, and in fact particularly, I think, clever in thinking about questions of logic. Anselm, for example, as I'm sure you all know, produced a sort of logical argument to establish the existence of God, the celebrated ontological argument. You know how it runs. Anselm says, let's define God. God is that being than which no greater can be conceived. So, so you begin to sort of list the qualities such a being would have. Obviously, that being would be omnipotent, wouldn't be limited in power, would be omniscient, wouldn't be limited in knowledge, so on and so on. What about existence? Surely to exist is greater than not to exist. Therefore, bingo, that maximal being must actually also be an existing being. It's an argument of astonishing virtuosity, but also it's, as we say in English, a fishy argument. Anselm has produced a divine rabbit out of a logical top hat. And that doesn't seem quite right. And I think, in fact, it was Immanuel Kant who showed how the trick had been done. You see, existence is not a defining predicate in the way that omnipotence or omniscience would be. Existence is of a different logical category. To state that something is existent is to say that there is a being satisfying all the true predicates that define that being's nature. No doubt, if there is a maximal being, that maximal being will possess aseity, will exist of itself and not owe its existence to anything else. That would surely be a maximal predicate to possess. But whether there actually is such a maximal being is a different question. And Anselm can't establish that by his logical argument. I know the arguments slop to and fro and are modified down the centuries, but it seems to me that Anselm, wonderful and remarkable man though he was, didn't quite pull off the trick. And in fact, Thomas Aquinas, of course, didn't subscribe to the ontological argument. He thought that wasn't the way to think about it. He produced his famous 5 ways, which are concerned with looking at the world. 4 of the 5 ways are concerned with rather general sort of features of the world. In the world there is change, but if the world persists, there must be some unchanging basis keeping it going, and so on. Those are arguments for an unchanging being behind the existence of the world. Only the 5th way, which is concerned with the aptness of living beings to survive and live in their environment, argument essentially of a design character, really depended upon somewhat more specific characters of the world. But it was during the second great period of natural theology, in the 18th century and the beginning of the 19th century, that the appeal to design, the appeal to the inspection of the world really got going in a big way. We associate it with people like John Ray, one of the sort of founding figures of biological taxonomy, whose book, the works of God manifested, the wisdom of God manifested in the works of creation, was an enormous bestseller. And of course, I suppose the thing reached its peak really with Archdeacon William Paley's celebrated book called Natural Theology. It was an uninhibited appeal to the extraordinarily intricate nature and aptness of living beings, like the eye, the oppositions of the thumb to the fingers, and so on. I don't need to elaborate. I'm sure you're all aware of that sort of argument. And it must have seemed extraordinarily convincing. And I'm sure it did convince a lot of people. But of course, as we also all know, in 1859, the rug was drawn from beneath that argument. And when Darwin showed how the patient accumulation and sifting of small differences over very, very long periods of time could produce the appearance of design without requiring the intervention of a divine designer. And after that, I think the enthusiasm for natural theology rather rapidly diminished. Burnt child fears the fire, so to speak. And of course also later on in the 20th century, Barthian theology expressed an extreme suspicion of any attempt to argue about the nature of God from any form of natural as opposed to revealed knowledge. So that's a brief history of natural theology, but I think we are today living in a period of revived natural theology again. And the interesting thing is that it has been revived in a revised form, and it has been largely revived, I think, by the arguments and investigations of scientists rather than of theologians. First of all, the revised form the natural theology takes today. First of all, it is more modest in its ambition. It doesn't try to trade in proofs. It doesn't try and say that if you don't believe in God, you are making an obviously foolish mistake. It doesn't trade in proofs, but rather it offers insight. The claim of the new natural theology is that to see a divine mind, for example, behind the order of the world gives you more profound, more comprehensive understanding than not to take that point of view. So it is insightful rather than logically coercive in its claims, and it attempts not to rival science, but to complement science. The mistake that Paley and his friends made was to offer theological explanations for scientific questions. How the eye developed is actually a scientific question, and of course eventually plausible theories of that were produced from evolutionary biology. And the fact that the eye has developed in various forms many times in biological history is also encouraging to that point of view. We have every reason, I think, to believe that scientifically statable questions will receive scientifically statable answers. Those answers may be very difficult to find, and there are obviously lots of questions which we are unable today to answer, like, for example, what are the processes by which first living beings, the first replicating systems developed? We don't know the answer to that. But if we're looking for an answer, as we surely should be, we are looking to science to help us to provide that answer. Science does not, in its own activity, require augmentation from theology. It will ask and answer its own questions. But we also have every reason to believe that there are many questions which it is both meaningful to ask and indeed necessary to ask, which are not scientific in their character, and which therefore, if they are to be answered, will have to be answered from some other source of insight. Science has achieved its great success by the modesty of its ambition. It doesn't try to ask and answer every question about the world. And interestingly enough, the new natural theology tends to look to questions that arise out of our experience of doing science, but which take us beyond science's self-limited domain of being able to answer. Questions that we might call meta-questions that take you beyond, or limit questions. And that's where the focus of activity has been. And incidentally, moving away from the idea that theology answers science's questions but answers other questions equally pressing and equally important is a response to a criticism that staunch Scottish skeptic David Hume had made about 18th century natural theology, that it was too anthropomorphic. It made God sound like a bunch of carpenters building a ship. It was too like human making. And indeed, if you think that God, puts the divine finger in from time to time, shapes things out, that does seem pretty anthropomorphic. That's what in Hebrew would be called asar. That's just ordinary making. But the Hebrew Bible, when it speaks about God's creation, uses a different word. It uses the word bara, and to give the fruitful order of the world, to endow the world with potentiality, is a divine creative act that has no human parallel. To see the Creator's presence and activity in that way is not to descend into an uncritical anthropomorphism. And I want to spend a little bit of time now asking and sketching what I believe to be sensible and to me persuasive answers to two particular meta-questions that have been at the basis of the new natural theology. And the first of those is a very simple question indeed. In fact, so simple that most of the time we don't even stop to think about it. And it's simply this: why is science possible at all? Why is it that we can understand the world around us in that deep sort of way? Well, you might say, Darwin will answer that question for you. If we couldn't understand the world in which we lived, then we would not be able to survive in that world. And of course, there's no doubt a good deal of truth in that answer as far as understanding the world on everyday terms is concerned. If we couldn't figure out that it's a bad idea to step off the top of a high cliff, then we wouldn't stay around for very long. Rather longer in East Anglia than in most parts of the world, but not all that long. So we've clearly got to have acquired a power to understand the everyday world. But of course, our powers of scientific understanding greatly exceed, in my view, anything that could be explained in simple evolutionary survival terms, or indeed explained as some happy spin-off from abilities developed for those survival purposes. It's one thing to figure out that you shouldn't step off the top of a higher cliff. It's quite another thing, it seems to me, for somebody like Isaac Newton to come along and an astonishing creative leap of the human imagination to see that the same force that makes the high cliff dangerous is also the force that holds the moon in its orbit around the Earth and the Earth in its orbit around the Sun, and through that to discover the mathematically beautiful law of universal inverse square law gravity, and in terms of that to be able to explain the behavior of the whole solar system. That's a leap of the human mind and the human imagination that goes far beyond anything, it seems to me, as banal, as simple, everyday survival necessity. Some of you, I'm sure, will be acquainted with the literature about Sherlock Holmes, and if you are, you may remember that when Holmes and Watson first meet in a novel called The Study in Scarlet, they are having breakfast, I think, in a London hotel, and Holmes is pulling Watson's leg from the start. And he says to Watson, I don't know, does the Earth go around the Sun, or does the Sun go around the Earth? And the good doctor is, of course, horrified at this apparent deplorable ignorance on the part of the great detective, and Holmes says, what does it matter for my daily work as a detective? And of course it doesn't matter at all. But we all know many things that we don't need for everyday living. Science is able to explore the universe and to understand aspects of the universe to a quite astonishing degree. Not just the everyday world, but that counterintuitive, completely different world of quantum physics, the world in which I worked myself for 25 years or so. Totally different world from the world of every day, where if you know where something is, you don't know what it's doing. If you know what it's doing, you don't know where it is. That's the Heisenberg uncertainty principle, of course. That world is cloudy, fitful in its behavior, totally different from the everyday world. Nevertheless, we can understand it. And the same thing goes, of course, for the vast expanses of cosmic curved space-time. The geometry of the universe is quite different from the geometry of the surface of the Earth. But again, we were able to understand that. Einstein, 200 years after Newton, was able to come along and, through another astonishingly creative leap of the human imagination, to discover general relativity, to present the modern theory of gravity, in terms of which he could not just explain the behavior of the solar system, but propose a model for the whole universe itself. He didn't get the model right, by the way, but that's the way science has to stumble along. So we have enormous powers. The physical world has proved to be deeply intelligible to a degree that surely is so striking, demand explanation. The world is rationally transparent to our inquiry, and not only is it rationally transparent to our inquiry, but it also has turned out to be rationally beautiful. It's turned out that the key to unlocking the secrets of the physical universe lies in mathematics. It's an actual technique in fundamental physics, a technique of discovery in fundamental physics, to look for equations which have the unmistakable mathematical characteristic of being beautiful equations. Some of you will know about the beauty of mathematics. Conceivably, not all of you will. It's connected with something like economy and elegance, something that the mathematicians call deep. Something is deep when a very simple-looking thing turns out to have very rich and almost inexhaustible consequences. Mathematical beauty is, like all forms of beauty, easier to recognize than to describe, but mathematicians can agree about it. And we found time and again that the equations which through their long-term fruitfulness persuade us that they really are describing aspects of the physical world are in fact mathematically beautiful. I suppose the greatest physicist I've known personally was Paul Dirac, one of the founding fathers of quantum theory, here in Cambridge, of course, professor here for 30 years or so. And Dirac once said, it is more important to have beauty in your equations than to have them fit experiment. Now, of course, he didn't mean that empirical accuracy was something that a scientist could dispose of. I mean, no physicist could believe that. What he meant was this: if your equations didn't at first sight appear to fit experiment, that of course was a setback, but it wasn't necessarily fatal, because maybe you hadn't solved the equations properly. Almost certainly you would have had to use some approximation, maybe you used the wrong approximation, or maybe even the experiments were wrong. We've known that happen more than once in physics. So there was at least some glimmer of hope that you might save the day. But if your equations were ugly, there was no hope. They couldn't possibly be right. The whole history, 300-year history of modern theoretical physics, testified against you. Dirac once said it was a very profitable religion that he and Schrödinger pursued to look for beautiful, beautiful equations. And he made his great discoveries exactly in that way. Now, when we use mathematics in that way, something really very extraordinary is happening. Because what's mathematics? Mathematics is abstract human thinking. Our mathematical friends sit in their studies, and out of their heads they dream up the beautiful patterns of pure mathematics. If maths isn't your subject, just think of it as being a pattern-creating, pattern-analyzing subject. What I'm saying is some of the most beautiful patterns that the mathematicians can think of have turned out actually to be instantiated, actually to occur in the structure of the physical world around us. Somehow or other, the reason within, the mathematical thoughts of our minds in this case, and the reason without, the structure of the world, the deep structure of the world, fit together. That's an extraordinary thing. Dirac's brother-in-law, Eugene Wigner, who also won a Nobel Prize for Physics, once said, "Why is mathematics so unreasonably effective? Why does this abstract tool turn the lock of the secrets of the physical world?" Well, that seems to me a pretty important question to ask. And if you're imbued with a thirst for understanding, as scientists certainly are, you'll want to try and make, not just shrug your shoulders and say, gee, that's just the way it happens to be, and a bit of good luck for you chaps who are good at maths. You'll want to try and make sense of that. Science itself won't be able to help you, because science and scientists simply rejoice that that's so, and are content to exploit the opportunities that it offers. Now, a deep question like, why is science possible? Why is the world rationally transparent and beautiful? Why is mathematics so unreasonably effective? That sort of deep question isn't going to have a knockdown answer. But I believe myself that a deep and satisfying answer to that question is provided by theistic belief, which says, for example, that the reason within, the reason without, fit together because they have a common origin in the rationality of the Creator, whose will both is the ground of our mental life and of the existence of the physical world of which we are parts. You can summarize what I've been trying to say by saying that as scientists study the world in its deep structure, they find a world shot through with signs of mind. And it is at least worth considering the possibility that that is because the capital M mind of the Creator lies behind the wonderful order of the world. Scientists, when they write books about fundamental physics particularly, quite like to use mind of God language. Sometimes they do it with their tongues in their cheeks, I'm sure. Sometimes they do it to try and sell books. But I think, nevertheless, there is a sort of instinct behind that that is worth treating with respect. So that's my first meta question. A theistic belief will make intelligible what otherwise seems to be an astonishingly happy accident about the way the world is. Second question is a little bit more specific, and that is, I can put it this way, it's to ask the question, why is the universe so special? Now, of course, scientists don't like things to be special. I mean, our instinct is to go for the general. That's what we like to think about, that's what we think the power of science derives from. And I suppose our natural supposition, all of us, would have been to think that the universe in which we live is just a pretty common or garden sort of universe, just a typical example of what a universe might be like. But as scientists have studied the universe, in particular have come to understand a great deal about its history, that history stretching over 13.7 billion years, as the cosmologists now say, they're getting very accurate, linking an initial expanding ball of energy, very, very simple physical system indeed, which after 13.7 billion years has changed into the rich and varied world that we see today, the home of scientists and saints. That history in itself, that move from simplicity to rich complexity, might of itself suggest that something more has been going on in that cosmic history than science itself would be able to articulate. But quite apart from that, as we've come to understand many of the processes by which that richness of structure has developed, we've come to see that it's only been possible because the basic physical fabric of the world, the given structure of the laws of nature, their form and the intrinsic strength that the forces of nature possess. In other words, the very things that science has to take as its given starting point, in terms of which it then seeks to explain, and often very successfully explain, the process of the world, that very given starting point itself has to be very specific, very special, to have been very specific and very special, to have enabled that fruitful history to happen. Of course, it's been an evolving history, and we'll think a bit more about that on Friday, which has involved an interplay between chance and necessity, between contingency and lawful regularity. What we have come to see is that the lawful regularity half of it has to be very specific, very finely tuned, one might say, for the evolutionary process to be capable of producing such a remarkable complexity as is represented by carbon-based life. It's a very surprising conclusion. I'm sure you all know that it's conventionally called the anthropic principle, and we want to spend a little bit of time thinking about it. The name anthropic principle is a little bit of an unfortunate thing. It's not being suggested that the world is finely tuned to produce Homo sapiens. Of course, there's contingency in our nature. 5 fingers have not been decreed from all eternity for human beings. But that the world is capable of producing carbon-based life in its rich complexity and potentiality doesn't seem to be just a happy accident. It's something that had to be present in the given physical fabric of the world, essentially from the start. As far as we know, there was no life in the universe until it was about 10 billion years old, and of course no self-conscious life like you and me until yesterday, really, in cosmic terms. But there's a very real sense in which the universe was pregnant with the possibility of life, had the finely tuned potentiality that would eventually enable that to happen right from the start, essentially, just after the Big Bang onwards. Very surprising conclusion. I'm sure many of you know lots about it, but let me just remind you of one or two of the things that persuade us. There are many, many arguments, and you can read big books, big fat books about it. If you're going to have a fruitful world, one of the most important things you have to get right is to have stars and to have the right sort of stars. And that's important because stars have 2 absolutely indispensable roles to play. One is simply the role of fueling the development of life on a suitable encircling planet. Life has been able to develop here on Earth over a period of 3.5 to 4 billion years because our local star, the Sun, has been shining essentially steadily, with some variations, but essentially steadily, reliably over that period, fueling the development of life. Now, we know what makes stars shine in that sort of way. Astrophysics is pretty good about how stars work. And the way stars shine depends very sensitively on a delicate balance between 2 of the fundamental forces of nature. Essentially, it's gravity and electromagnetism. And if you shift the balance between those 2 forces, and you don't have, because it's sensitive dependence, you don't have to shift it all that much. If you shift that balance a bit, then the whole behavior of stars will change. If you shift it one way, stars will begin to burn immensely intensely. They will simply pour out energy. And the result of that will be that they won't live very long. In our universe, stars live 10 billion years average, something like that. In a universe where they're just burning away, they will only live millions of years. And that's not long enough to get life going. So you've got to have stars that don't burn themselves out too quickly. Equally, of course, you have to have stars that are not too dull and never really produce enough energy. So there's quite a narrow band where the stars will do their trick. And of course, obviously, that we live in a world which has that condition. That's one condition. But the stars have a second thing to do. They have to be able to produce the chemical raw materials of life. Because the very early universe is very simple, it only, during the 3 minutes or so in which it's a sort of cosmic hydrogen bomb, nuclear processes taking place all over the universe, it only produces very simple consequences. In fact, the very early universe simply makes the two simplest chemical elements, hydrogen and helium. And the universe finished off on the gross scale as being 3/4 hydrogen, 1/4 helium. Now, those two elements, of course, have a pretty boring chemistry. You can't really do very much with hydrogen and helium. You need lots more elements. You need 20 to 30 elements for life. You need, for example, carbon. I mean, the biochemistry, the chemistry of life, is the chemistry of carbon. It's carbon that enables these great long chain molecules to come into existence. But the early universe doesn't make any carbon at all. So where does carbon come from? Well, there's only one place in the whole universe where carbon is made. It's made in the interior nuclear furnaces of the stars. Every atom of carbon in our bodies is once inside a star, where people have met stardust, made out of the ashes of dead stars. One of the great triumphs of astrophysics in the second half of the 20th century, and a lot of it happened here in Cambridge, was to figure out how the heavier elements are made in the stars. And one of the people who did a lot of work on it here was Fred Hoyle. And these chaps were having a lot of difficulty in getting going. They've got helium. And if they could make 3 helium nuclei stick together, that would produce carbon-12. Helium-4 would turn to carbon-12. But of course, it's essentially impossible to get, with small things like nuclei, to get 3 of them to stick together at the same time. So if you're going to do that, you're going to have to do it sequentially. So the obvious idea would be you stick 2 of them together. That makes beryllium-8. You hope that stays around until some other helium comes along, turns beryllium-8 into carbon-12. But that doesn't work. And the reason it doesn't work is that beryllium-8 is very unstable. It doesn't stay around long enough for that extra helium to stick on, anyway, in an ordinary sort of way. So they were absolutely stuck from the start. They didn't know how to make carbon. And then Fred had a good idea. He saw that if there was a resonance in carbon, a substantially enhanced effect, at just the right energy, it had to be the right energy to accelerate this sticking on process. If there was a resonance in carbon at a particular energy, then the sticking on process would go faster than you thought, and you would just be able to catch some of the beryllium-8 and turn it into carbon before it disappeared. So Fred's very pleased with himself, and he goes to the nuclear data tables, and he looks up just to check there is this resonance at this energy, and it's not there. But he knows it must be there, because this is the only way you can make carbon. Fred's carbon-based life, after all. He knows that it must be made. So he rings up some friends of his in the United States called the Lauritsons, who are very clever experimentalists. And he said, look, you chaps have missed something. There's a resonance in carbon you've missed, and I know exactly where it is. You can go and look for it. I'll tell you where to look. Apparently they didn't want to look. It was quite a tricky experiment, but Fred was pretty determined when he gets the bit between his teeth. And they looked, and they found it. It's a wonderful scientific story, that. To predict the resonance level in carbon, an undiscovered resonance level in carbon, through thinking about astrophysics in stars. I mean, it's sensational. He should have got a Nobel Prize for it. That's another story. But after he'd done this, Fred realized, of course, that if the laws of nuclear physics had been only a little bit different, there either would not have been a resonance in carbon-12 at all, or it would have been somewhere else, where it wouldn't have been useful. And he is reported to have said, in a Yorkshire accent that it's beyond my powers to imitate, the universe is a put-up job. In other words, Fred, atheist though he was, lifelong atheist, couldn't believe that fine-tuning in the nuclear forces that had enabled carbon to be made in stars could be just a happy accident. He didn't like the word God, of course, so he said there must be some capital I intelligence behind all this. And of course the story goes on. It's a very, very beautiful scientific story, the story of nucleogenesis in stars. Because you've got to make sure, you stick another helium on, that'll give you oxygen-16. You've got to make sure that doesn't have a resonance, because otherwise you'll lose all the carbon. You can get up to iron-56, but that's the most stable of all nuclear species. You can't get beyond iron inside stars, but you need elements beyond iron. But it turns out that when some stars explode as supernovae, scattering the elements they've made already, the neutrinos that drive off the outer envelope of the star induce further nuclear reactions that make the heavier elements beyond iron in acceptable abundances. It's a very, very beautiful story. And it's a very, very finely tuned story. So there we are. You could go on and on about these things. There are lots of other considerations, even the size of the universe, for example. I mean, you all know that our galaxy, the Milky Way, has 100,000 million stars in it, and that there are about 100,000 million galaxies in the observable universe. We live in an absolutely immense world, and that's often a slightly off-putting thought. I mean, here are we, the inhabitants of a speck of cosmic dust. Can there be any significance in us? Well, if all those stars weren't there, we wouldn't be here to be upset at the thought of them, because only a universe as big as ours could last the 14 billion years or so that you need to be able to develop carbon-based life, and so on and so on. The most accurate of all these things is the estimating the strength of, well, we used to call it the cosmological constant. Now people call it dark energy, the energy associated with space itself, which, well, different people seem to estimate in different ways, but it's something like 10 to the minus 120 of what its natural value would be. And if it were not so terribly tiny, either the world would have collapsed just like that, or it would have flown apart, become too dilute for anything to happen. So there's a lot of fine-tuning in the world, and everybody scientifically agrees that that's the case. I mean, there's no ifs or buts about that. Where the ifs and buts come in, of course, where the argument begins, and rightly begins, is what is the significance of that? What are we to make of that? And in thinking about that, let me tell you, you've probably heard this story before, but let me tell you a story. I think one of the most interesting writers about these anthropic principle things, and certainly good to read, is John Leslie, who wrote a book called Universes, which is worth having a look at if you're seriously interested in these matters. Leslie is a philosopher, and he's an interesting philosopher because he's a parabolic philosopher. He does his philosophy by telling stories. And that's very agreeable to somebody like me who's not trained in philosophy, because we can all understand stories. And here's one of the stories he tells. You are about to be executed. You are tied to the stake, your eyes are bandaged, the rifles of 50 highly trained marksmen are leveled at your chest. The officer gives the order to fire, the shots ring out, and you find you have survived. So what do you do? Do you just shrug your shoulders and say as you stroll away, gee, that was a close one? I think probably not. So remarkable an event calls for an explanation. And Leslie says, if you think about it, there are only two sorts of explanation. One might be this. One might be that maybe there are just many, many, many executions taking place today. Even the best of marksmen occasionally miss, and you happen to be in the one where they all miss. That becomes a rational possibility if there are lots and lots, and there really have to be a tremendous number, obviously, of executions taking place today. You've just drawn the lucky ticket, so to speak. But of course there is another explanation, which is that maybe there's only one execution scheduled for today, namely yours, but more was happening in that incident than you are aware of. The marksmen were on your side, and they missed by design. Well, you see how that charming story translates into thinking about the anthropic fine-tuning of the universe. First of all, of course, if it wasn't there, we wouldn't be here. If the universe wasn't fit for carbon-based life like you and me wouldn't be here to cogitate about it. But the circumstances that permit us to be here are so remarkable that it isn't a rational thing just to shrug our shoulders and see, gee, that's the way it is, any more than it. Of course, the chap who survived the execution couldn't have questioned his good fortune if he hadn't actually survived it, but it does call for an explanation. So Leslie says, and so I believe. And there are two possible explanations, really. One is maybe there are just lots and lots and lots, and again there has to be a vast number, of different universes, all with different laws of nature, different strengths, different forms of the laws of nature, and so on and so on. And if there are enough of them, then of course, in this vast portfolio of different and disconnected worlds, in that vast portfolio, one of them, just by chance, may be okay for carbon-based life, and that's the one in which you and I live, because of course we are carbon-based life. That would be the multiverse, the many-universe explanation, paralleling the many executions explanation. Our universe is just, by chance, a winning ticket in the multi-cosmic lottery. It's a rational possibility. But of course there's another rational possibility. Maybe there is in fact only one universe, our one. But maybe it is the way it is because it is not just any old world, but is a creation which has been endowed by its creator with precisely the finely tuned laws and circumstances that have permitted it to have a fruitful history. That would be, of course, the creation explanation. So what are we to go for? Multiverse or creation? I believe that either explanation is meta-scientific. People dress up the multiverse arguments either through Moneyworld's quantum theory or string theory or whatever. But I think there are no genuine scientific arguments. We could argue about this later if you like. I think there are no genuine scientific arguments to persuade us we ought to believe in the existence of any unobservable universe. We only have good scientific motivation for believing the existence of our world. So I think the supposition of a multiverse is a metaphysical, meta-scientific supposition, just as, of course, obviously, the supposition that there is a creator God is a meta-scientific, metaphysical supposition. So it seems to me that the two offered explanations are operating at the same level. Which do we choose? Well, Leslie says it's 6 of one and half a dozen of the other. You don't know which to choose. Each does the explanatory work. And I think myself, actually, as far as the question of anthropic fine-tuning is concerned, he's probably right about that. You could have one or you could have the other. But it seems to me that the hypothesis of a multiverse only actually does one piece of explanatory work. It explains, or it explains away, according to how you think about it, the fine-tuning of our particular universe. But the assumption that there is a creator of the world, the theistic assumption of a creator of the world, does a number of explanatory pieces of work. It explains, of course, the fine-tuning of the world in the way we've been thinking about. It also, I have already suggested this morning, offers an explanation of the deep rational order and beauty of the world. So it has an extra sort of thing going for it in that respect. And of course it explains many other things. It explains, for example, the origin of the widely testified human experience of encounter with the sacred. So it seems to me there is a cumulative case for theism in which the fine-tuning of our anthropically fruitful universe is one argument that sort of stacks up. And I don't see things stacking up on the multiverse side. So I think there are rational grounds for preferring, as of course I personally do, the design explanation. So that's what the new natural theology, it seems to me, looks like. It's concerned with meta questions. It isn't concerned with telling science how to do its own job. It's concerned with taking absolutely seriously what science can tell us and seeking to incorporate that understanding within a broader and deeper setting of intelligibility to make sense of the world. It is of course a limited form of inquiry. If you give me absolutely the maximum success and persuasiveness of the arguments that I've been trying to present to you this morning, it will only lead you to a picture of God as something like the great mathematician or the cosmic architect. It will be a very impersonal picture of God. It will be a picture of God as consistent with deism, that God is simply set the world spinning and lets it get on with it, as it would be with theism. Thinking about those issues tomorrow, of a God who is in some way interacting with the unfolding history of the world. So it's a limited, it looks to a limited swathe of experience, and it offers a very limited picture of God. You can open it up a little bit more by pursuing another theme of natural theology, which is to point to the, moving now away from science itself, to point to the existence of value in the world. The world that science describes is not only a world of beautiful and fruitful order, it is also a world that is the carrier of beauty and the arena of moral choice. And where do those values? I myself take very, very seriously our experience of value. I think we have real moral knowledge. I think my belief that torturing children is wrong is not some curiously disguised survival to propagate my genes. I don't think it's a convention of my society. I think it's just a moral fact about the world. And where does it come from? I think also our encounters with beauty. Of course, they're culturally shaped in various ways, but I think there is an authenticity about them that makes us take them seriously too. And of course, if you believe that there is a God who is not only the ground or the order of the world, but the source of value, so that our moral intuitions are intimations of God's good and perfect will, and our aesthetic experiences are some degree of sharing in the Creator's joy in creation, you gain a further explanatory, to my mind, persuasiveness in a theistic view of the world. So you can extend it a bit that way. But you won't get to the particular understandings of God that you find expressed in the particularities of the different world-faith traditions. To look at that, you have to look somewhere else. You have to take the risk of entering into the richer and more ambiguous realm of personal experience as opposed to impersonal survey of the world. One of the interesting participants in the revised natural theology has, of course, been Paul Davies with his books God and the New Physics, and then what he himself describes as a more considered book, the Mind of God. And Paul is interesting because he doesn't sign up to any faith tradition. I think doesn't have much understanding of any faith tradition, to be perfectly frank. But nevertheless, he feels that what he learns from science tells him there is a deeper story to be told than science itself can articulate. He says, I think it's in the preface to God and New Physics, I see nevertheless no sign of the personal God of the Jews and Christians. And of course he doesn't, because he isn't looking in the right place. If you're going to encounter that sort of understanding of God, and of course there are many, many different understandings of God in different faith traditions, then you have to be prepared to enter into different realms of experience than we've been discussing this morning. So it's a limited form of inquiry, but I think it's nevertheless not without value. It would, I started off by saying, I think it'd be very unnerving if our inspection of the world and the use of our general reason didn't give us at least some hints of a belief of a reason for belief in the Creator. I am not at all claiming that atheism is stupid. I have many very intelligent atheists and friends, but I think I do claim that theism is capable of explaining more. I think it makes more comprehensive a deep sense of the world. And therefore, if the new natural theology helps to exhibit that a little bit and puts these issues and questions of theism onto the agenda of thinking people, then I think that's a worthwhile thing to do. That's what I think, but now I'd be interested to know what you think, and perhaps we can now move over to having a bit of a discussion.
Thank you very much. I'm sure there will be lots of discussion on that. Yes, I can see hands going up. Let's start over this side.
A number of 17th century natural theologians that I've read talk about the being and attributes of God. I think that the view of natural theology you've presented, you've considered whether the being of God, the existence of God, could be considered from nature. Do you think examining nature can tell us anything of what that God is like?
Well, I've been suggesting that it only gives one a limited understanding in that respect. We see a God of order, a God, it seems to me, of purpose. I ought to have said, I meant to say this at the end, that I haven't this morning discussed at all the problem of evil and suffering in the world. I haven't done that because I hope to say something about that on Friday morning. And the Achilles heel of natural philosophy and the serious problem which it has to acknowledge and to address obviously arises from the ambiguous character of the world. We see God's power, if you like. Do we see a God who cares about what's happened in the world? When we think about tsunamis and so on, there are very deep questions there which I absolutely don't want to dodge, and I'll try and say something about on Friday morning, so that that remains an issue. I mean, David Hume, of course, again, very much drew attention, rightly drew attention to the ambiguity of the world in that respect, and said, well, maybe the world is just the botched attempt of an infinite deity trying to find out how to create a world. And you can't say that you can immediately dismiss that point of view. So we'll only learn a little bit. And of course, in a sense, obviously, no finite argument of natural theology, this is another argument of Hume, no finite argument of natural theology could establish the infinite power of God. I mean, if God's the mind behind the order of the world, it's a pretty powerful mind, but is it unlimitedly rationally powerful? You couldn't claim to demonstrate that. And you couldn't claim, this is in some ways connected again with the ambiguity of the problem of evil and suffering, you couldn't claim that you've established a single divine mind lies behind the order of the world. So there are lots of limitations, and I acknowledge those. But of course, I'm sure I would be misleading you if I for a moment suggest that my own personal religious belief depends principally upon the sort of arguments I've been trying to discuss this morning. It lies elsewhere in my Christian encounter.
Thanks. A question over here. Yeah, at the back, sorry, first.
We'll get round to everybody, I'm sure.
Yeah. You've got half an hour.
Thank you very much for your talk. I especially like the way you employed the fine-tuning argument as a part of the cumulative case and broke the tie between multiverses and theism by noting all the other explanatory work that theism does. There is one issue that I hope won't be tedious to those.
Can you speak up a bit? I'm a bit deaf.
A bit more slowly and louder, yeah.
Okay. There is one issue that came up last week. I hope it won't be tedious for those who are here, regarding the claim that the great many galaxies and stars and so on out there are necessary for our universe to last as long as it has. That can't be right, because the Friedman equation is a local equation. It cares about the density in our neighborhood, but we solve it piecewise and can match it to an exterior Schwarzschild vacuum solution, for example. And everything would as far as the scale factor is concerned, be the same in our neighborhood. So it seems like some explanation for the vastness of the visible universe is a good idea. Perhaps God's displaying his glory would give us such an explanation. But it can't be the case that the longevity of the universe is that explanation. There must be some further premises that go in. And I think the argument's probably question-begging. By assuming homogeneity.
Well, that's that's a rather technical question. I'm not a cosmologist.
Can you rephrase it for those of us that aren't cosmologists, John?
Oh well, I mean, you're suggesting that the argument the universe has to be about as big as it is a little bit slick. The basis of the argument is to say that the universe must stay around for about 14 billion years and must not, in the course of that history, become rapidly too dilute. That's the and if you're going to have something like that, and you have the simplest picture of how you would establish that, then you will conclude that you're going to have a universe of about the density and about the age that we see, and therefore about the 10 to the 22 stars that we see in the observable universe. Now, I don't doubt that you can construct clever cosmologies exploiting inhomogeneities and so on, which would be different from that. But that doesn't, first of all, it doesn't seem to be the universe, and we don't see these inhomogeneities, do we? So I'm not sure I'm doing justice to you, but if I'm not, you put me right.
Well, no, I guess we don't disagree very much. But it sounded like the argument was if there were just empty space out there, then out there past, I don't know, a few thousand light years, whatever your favorite number is. I may have to pick a number more carefully. Then the universe would not support life. But I mean, the issue is the density. It's not the overall mass, as far as solving Einstein's equations is concerned. So I think we pretty much agree if you admit that homogeneity is built into that argument. But that unfortunately makes it circular.
That perhaps encourages me to make a general point. Of course, first of all, I've given a very broad brush account of these things, and if you want to read books to look at these things in much more detail, which you have to do if you're trying to be scrupulous about it. And incidentally, Rodney Hole's written a useful book which came out a year or two ago, which does that in an up-to-date fashion. There will always be fluctuations in the detail of these arguments, in the nature of things. But my own intuition, I think this is a genuine intuition, not just a disguised religious affirmation being passed off as science, is that the as we understand the complexity and interlocking and entangling character of the processes that have made the world the way it is, there's always going to be something special and sensitive about the way that's operated. For example, you're always going to. I take a very simple intuition. One of the simple intuitions of science is that for a world capable of producing novelty, you must have a world that exists at the edge of chaos. You must have a world that combines both order and disorder, interlacing with each other. If you don't have order, things will just never persist. If you have too much order, nothing changes. So you have to have a sort of flexibility. Now, I don't myself doubt for a minute that the kind of physics that quantum physics represents is fundamental to providing part of that existence at the edge of chaos that makes our world fruitful. And sometimes over bold cosmologists speculating about how the universe might have originated from some vacuum fluctuation say, aha, we've solved the problem theologians couldn't solve. We've brought into being a world out of nothing. But even if they're right in what they say, and I think that's open to investigation, even they're right in what they say, a quantum vacuum is not nothing. Where does quantum theory come from? Where does general relativity come from? I mean, there's going to be something special about the world. And I think quantitative is special as well. Sorry, that's
Paul.
that's move around a bit.
Thank you for what I thought was a superb exposition. You said near the beginning that scientific questions ought to have scientific answers.
Right.
Now, is the question of why the gravitational interaction is 10 to the 40 times weaker than the electromagnetic interaction a scientific question? Is the value of the cosmological constant a scientific question, or is it a meta question? If it received a scientific answer, would that do away with the sort of meta answer? I don't know if the question makes sense.
Yes, no, absolutely. Well, I've been treating this morning the constants of nature, like the ones you've just referred to, as being scientific givens, and in terms of what you might call normal as opposed to boldly speculative science, that's the way we do it. And in terms of these things, we see the process of the world. So if that's the case, then why gravity is so much weaker than electromagnetism is it's not a scientific question. It's a scientific given. Now, of course, there is a hope that when people find the grand unified theory, the theory of everything, as they modestly call it, that somehow or other there will turn out to be no adjustable parameters in the world, or very, very few. So all these apparently arbitrary ratios, like 10 to the minus 40 or whatever, are somehow fixed, intrinsic to what's going on. Now, my generation of physicists are extremely suspicious of those claims. They don't think they're going to work. But even if they did work, they would work on this basis, that there's only one theory that truly and properly integrates quantum theory, general relativity, or whatever else general principle we want to put in. Now, if it turned out that was right, and if it turned out that the forces determined by that theory were precisely those that enable the development of carbon-based life, that would seem to me to be the most astonishing anthropic coincidence of all. A no-parameter theory to do the trick is more striking than a theory with those sort of parameters. Of course, it doesn't really look like that. I mean, the string theorists at the moment, some of the string theorists think there are 10 to the 500 different forms of string theory. And some of them are bold enough to say, therefore, there must be 10 to the 500 universes in which they're all realized. But the spirit of physics has changed a lot in recent years. I mean, I was in the game when it was experimentally driven. And there were very, very clever theorists around, people like Gell-Mann and Feynman and people like that. But essentially, the development of the subject was driven by the discoveries of the experimentalists. Since then, two things have happened. One is the experimental input has declined very, very greatly, partly because the taxpayer won't pay for the cost of getting it. And the speculative boldness of theorists has, in consequence, increased enormously, unbelievably so. And there's a very big generational divide. Well, there we are. Sorry, I mustn't get carried away. Yep.
Straight behind Rodney.
You mentioned that one of the main characteristics of revised natural theology is that it must be modest.
Yeah.
So there's a contemporary natural theologian who says that according to Bayesian reasoning, the probability of God's existence is slightly higher than the probability that God doesn't exist.
Right.
Do you think this kind of natural theology is modest enough?
Well, you have sitting in front of you a chap who also is prone to appeal to basic. Yes, obviously. No, yeah, I realise that. Yes, but well, I mean, I think those arguments are interesting. The trouble with, I mean, if I may say so, I'm not a statistician at all, but the trouble with base statistics is about how evidence enhances your confidence in what you think. But what you have to feed into the equations is your prior confidence, the prior probability. An atheist can logically put in the probability, prior probability 0 for God, and then any old fine-tuning will not enhance that beyond 0. So you'll never, there are inescapable, and I think it's not surprising, inescapable matters of judgment that you have to make, which can't be, they can be helped in interesting ways by these mathematical calculations. I certainly don't despise them. In fact, I think they're very interesting, but they will not settle the issue for us. There isn't just as there isn't a computer that can be programmed to win a Nobel Prize for physics, so there isn't a computer that can be programmed to answer the question, does God exist? So I think you have to be modest, but you have to sort of have a combination. My favorite philosopher of science is Michael Polanyi, and Polanyi very clearly recognized, he was of course himself a distinguished scientist, he clearly recognized the precarious and circular nature of scientific argument. Theory interprets experiments, experiments confirm or disconfirm theory. You can't get out of the circle in some respect. But he was also emphatic that science was sufficiently successful to be the ground for commitment to belief. He said he wrote Personal Knowledge, which is his greatest book, to show, he's talking about science, remember, show how I may commit myself to what I believe to be true, knowing that it might be false. And that, I think, is the human condition. It's as true of theology as it is of science. And we can't escape from that. But that's another reason for modesty, but not, I think, for intellectual paralysis.